My name is Anthony Guglielmi, and I will be talking about the first stars in the universe. On a clear night sky, thousands of stars are visible to the naked eye. These stars account for only a small fraction of the total number of stars that make up our universe. According to modern cosmology, the universe was at one point nearly featureless and almost entirely dark. The first stars did not appear until nearly 100 million years after the Big Bang. Decades of research and observations have made great headway in describing such a dramatic transition from almost complete darkness to such profound light. Computer models showing how density fluctuations left over from the Big Bang could have evolved into the first stars, as well as observations of distant quasars, have gone a long way in helping cosmologists gain an understanding of how the first stars formed. It is believed that the first stars were quite massive and luminous, and that their formation was an event that essentially changed the universe and its subsequent development into the universe we see today. The first stars produced and dispelled the heavy elements which eventually gave rise to the formation of solar systems. Likewise, it is believed that the collapse of the first stars may have initiated the growth of supermassive black holes that lie in the center of many galaxies we see today. Basically, the earliest stars made possible the development of the modern-day universe, and all of its components, including, most surprisingly, humans. Cosmologists can make assumptions about the early universe based on the cosmic microwave background radiation, which was emitted about 400,000 years after the Big Bang. Although the early universe was very smooth, the background radiation shows evidence of small-scale density fluctuations or clumps in the primordial universe. It is believed that these clumps evolved into gravitationally bound structures and formed small systems. The denser regions of these systems would take the form of the first star-forming systems referred to as proto-galaxies. According to computer models, these small systems capable of forming the first stars should have appeared nearly 200 million years after the Big Bang. These proto-galaxies would have been 1 million times more massive than the Sun. The first proto-galaxies would have consisted mostly of dark matter and would have contained no significant amounts of any elements besides hydrogen and helium. Simulations reveal that these primordial gas clouds or proto-galaxies began to contract because of their gravity. This compression would heat the gas to temperatures above 1000 Kelvin. Hydrogen atoms would begin to pair in the dense hot gas, and the formation of molecular hydrogen would occur. The hydrogen molecules would then start to cool the densest parts of the gas by emitting infrared radiation after collisions with hydrogen atoms. The temperature would drop to 300 Kelvin in these dense regions, reducing the gas pressure and allowing for the contraction into gravitationally bound clumps. This cooling allows ordinary matter to separate from the dark matter. The cooling hydrogen would settle into a flattened rotating disk, and the star-forming system would almost resemble a small galaxy with a disk of ordinary matter and a halo of dark matter. Inside the disk, the densest clumps of gas would continue to contract. The first star-forming clumps were much warmer than the molecular gas clouds in which most stars currently form. Likewise, these star-forming clumps are hundreds of times as massive as the Sun. Some of these clumps of gas continue to contract and become very massive luminous stars. As you can see, the first stars were believed to have much larger masses, radii, luminosities, and surface temperatures than the Sun, although they were believed to have a much shorter lifetime. Ultraviolet radiation from the first stars ionized the surrounding neutral hydrogen gas, and as more stars formed, the ionized gas blobs merged and intergalactic gas became ionized. After a few million years, at the end of their lives, some of the first stars exploded as supernova, while the most massive stars collapsed into black holes. Gravitational attraction then pulled the proto-galaxies toward one another, and it is likely that the subsequent collisions also triggered star formation. Finally, black holes possibly merged to form a supermassive black hole at the proto-galaxy's center, with gas accretion having possibly generated quasar-like radiation. The birth and death of the first stars and proto-galaxies began a process of cosmic evolution and eventually gave rise to light and life. In the coming years, researchers hope to learn more about the early stages of the first star formations when structures started developing on the smallest scales. Recently, astronomers have detected what they believe is shadows of light emanating from the very first stars of the universe. The new discovery about the early universe was discovered using the Fermi Gamma Ray Space Telescope. Fermi has detected the glow of the first stars called extragalactic background light, and using complex formulas has filtered out light from newer stars, isolating light from the early universe. The results are setting the stage for what's to come. In simple terms, Fermi is providing us with a shadow image of the first stars, whereas the James Webb Space Telescope, which will be in orbit by 2018, will be capable of imaging the first galaxies in the cosmos directly. Although this won't be quite as good as seeing the individual stars, which are far too distant for any conceivable telescope to pick up, it will, however, be one more big stride towards understanding what really happened during the dark ages of the universe.